Hey guys, in this video we're going to be looking at some examples on how to add, subtract, multiply, and dividing complex numbers. So what a complex number is any, equation that has an I thrown in. Okay, so let's look at the adding one. When adding, of course, there's no need for parentheses because no signs changes, so we can just rewrite this as 4 plus I plus 7 minus 5I. And then we're just going to combine our like terms and simplify. So we have a 4 and a 7. So 4 plus 7 is going to give us 11. And then we have a single I by itself, so we know that's one I, minus 5I, which is going to give you negative 4I. And since we can't break that down anymore, this is our final answer. One thing you need to know about complex numbers is their answer is always going to end up in the form as A plus BI. So basically your constant, just the number by itself, and then what's going to go second is the number that has an I attached. Okay, let's look at a subtracting example. So in subtraction, it's really important to pay attention to the parentheses because if there's a negative in the front, we have to distribute that negative to all numbers inside of there. So since there's nothing in front of the 6I, that's just going to stay, 6I. There is a negative in front of this parenthesis, so it's going to become negative times 14, which is negative 14. And then it's going to be a negative times a negative I, which of course becomes a positive I. And then since it's just a positive sign in front of the parentheses, we don't have to change anything. We can just write it as plus 5 minus 3I. And then same thing as we did up here, we're just going to combine our like terms. So let's look at our constants first. We have negative 14 plus 5, which should give us negative 9. Then let's look at our terms with i's on them. Okay, so we have 6 plus 1, which is 7, minus 3, which is positive 4. And once again, we can't simplify that any further, so this will be our final answer. Let's look at how to multiply some. So of course, if something's on the outside of our parenthesis, that means we're multiplying everything inside the parentheses by that. So it's going to be 2 times 8, which is 16. It's just going to have an I on it because the 2 had an I. Now we have minus 3 times 2 is 6. And we have I times I, which is I squared. Okay. If you remember from our last lesson, we can simplify I squared. So we have 16I minus 6. If you remember, I squared is the same thing as negative 1. So now this is going to become 16I plus 6 because it's negative 6 times a negative 1, which is positive 6. And then once again, we need our constant first, so we're going to reorder it as 6 plus 16I. And there's our final answer. Let's look at another multiplication one. So this one's really important. I want to make sure you pay attention to this one because there's a square on the outside. So a lot of people are saying, okay, we can just multiply that in. That is incorrect. Anytime there's a squared on the outside, that means we're going to have to write that parentheses twice. If it was cubed, then we'd write it 3 times. But in this case, it's just squared, so we have to write it once. Okay, now that we have 2 sets of parentheses, we're going to FOIL. So first, outer, inner, last. Okay, so first, 6 times 6 is 36. Outer, 6 times a negative 2i. 6 times negative 2 is negative 12i. Inner, negative 2i times 6, which is negative 12i again. And then last, we have negative 2 times a negative 2, which is positive 4. And we have I times I, which is I squared. Now we just simplify. So these two are like terms. So we can rewrite that as 36 minus 24i plus 4i squared. And then once again, you don't want to keep it as I squared. We're going to rewrite that as 4 times a negative 1 because we know that I squared equals negative 1. So we're going to simplify a little further. Now we have 36 minus 24i minus 4. And now we can combine our like terms. We have 36 minus 4, which is going to give us 32 minus 24 I. And we can't simplify that any further, so that's gonna be our final answer. Now we're gonna look at some dividing examples. So out of all of these, dividing complex numbers will be the most complicated. And why that is because we can't have an I in the denominator. So when it's an example like number 1, when it's just like a term with an I, all you have to do to get rid of that is you're gonna have to multiply top and bottom by I. Okay, so 4 times I gives you 4I, and then negative 9I times I will give you negative 9I squared. Then of course we're gonna rewrite that. We can't rewrite 4I. We can rewrite the I squared as negative 1 because I squared equals negative 1. We're going to keep 4I the same. Now we have negative 9 times a negative 1, which is positive 9. And this will be our final answer. So the ones like these are pretty simple. Where it gets a little more complicated is examples like these two. So when it's like this one right here, we didn't have like two separate terms. We just had one term in the denominator. On examples like these, see how we have two, like where there's a sign in between it? When you have a problem like that, you have to multiply by the complex conjugate, which I know sounds extreme. It's really not. All it is you take the denominator and you switch the sign. So right now it's 5 minus 1. I'm sorry, 5 minus I. So how we'd rewrite that is 5 plus I. So we multiply top and bottom by the complex conjugate, which once again, all that is your denominator, and then you change the sign. If in the original problem, if it's a positive, then you multiply with, a negative in between there. Okay, and then of course we just actually multiply. So we have negative 2 times 5, which is negative 10. We have negative 2 times I, which is negative 2I. On the bottom, we're going to have to FOIL. So first times first, 5 times 5 is 25. Outer, which is 5 times I, which is plus 5I. Inner, which is negative I times 5, so negative 5I. And then of course last, which is negative I times positive I, which will give you a negative I squared. So then we want to rewrite this denominator. So we're going to have negative 10 minus 2I up top, and on the bottom we're going to simplify. We have 25, then we have a positive 5I and a negative 5I. So of course a positive 5 and a negative 5 are going to cancel each other out, and that right there is the whole purpose of multiplying by the complex conjugate, because we want those i's to cancel each other out. If for some reason yours did not, cancel it out, you've done something wrong, so I'd go back and rework that problem. Okay, so those cancel out, and then of course we have a negative I squared. Okay, so we have negative 10 minus 2I over 25 minus, well, we know I squared is the same thing as saying negative 1. Okay, so we're going to rewrite that, of course, now as negative 10 minus 2I over 25. Negative times a negative 1 is positive 1. So that leaves us with negative 10 minus 2I over 26. And then the very last step is all of these numbers can be divided by something. They can all be divided by 2. So of course we're going to do that to make it in its simplest version. Negative 10 divided by 2 will give us negative 5. Negative 2I divided by 2 will just give you negative I. And then on the bottom, 26 divided by 2 will leave you with 13. So this right here will be your final answer for that one. Okay, let's look at one more example like that and dealing with the complex conjugate. Once again, all that is you're going to take the denominator, so it's 2 plus I. So the complex conjugate is just going to be 2 minus I. We're multiplying top and bottom by the complex conjugate. Okay, so foiling. First, 7 times 2 is 14. Outer, 7 times a negative I is negative 7I. Inner, 3I times 2 is positive 6I. And outer, 3 times a negative I is negative 3I squared. On the denominator, same thing, we're foiling. First, 2 times 2 is 4. Outer, 2 times negative I is negative 2I. I times 2 is 2I. And then lastly, I times a negative I is negative I squared. Okay? Up top, we're going to simplify. we have a negative 7i and a positive 6i, leaves us just with negative I, minus 3, we're going to rewrite I squared as a negative 1, over 4, we have a negative 2i and a positive 2i, so this cancels each other out, which is what we were hoping for. And we have minus I squared, and we're going to rewrite I squared, of course, as negative 1. So now we're going to simplify a little more. 14 minus I, then we have negative 3 times a negative 1, which is, of course, positive 3. And on our denominator, we have 4 minus a negative 1, which becomes plus 1. We're going to simplify a little more. We have 14 plus 3, which is 17, minus I over 4 plus 1 is 5. And since we can't simplify that any further, here's your final answer again.